Hello everyone, my name is Ben and I am the co-founder and distiller at Puddingstone Distillery, the home of Campfire Gin. And David has asked me to speak to you today about the subject of ultrasound and its application in the distilling process. Bit of disclosure here, I asked my mate the other day, who's a videographer, if he would come over to the distillery. He asked me whether we'd be trying gin. I said no, we'd be filming a piece about ultrasound. He told me to fuck off. So here I am on my own, and that means that you're going to have to put up with some rather shaky editing. 1 minute I might be here, the next I'm going to be over here. A bit of context. First of all, those of you who know me will know that I am not a chemist. I don't have an engineering background. My background is from creative pursuits, basically. We tend to approach the development of our gins with a high degree of creativity mixed with a equally high degree of naivety. We might have done a bit of research as well. I am definitely not a scientist. We've not taken anything that we do here lightly, and certainly not the project we're going to talk about. And the project we're going to talk about is the Ultrasonic Gin, produced in collaboration with the Hertfordshire and Middlesex Wildlife Trust. It's an organisation that we've worked with for 4 years now. For the previous 3 years, we had been the first distillery to use a non-native invasive plant species as a botanical. That was built around a clearing project, basically. So what we ended up doing was effectively destroying the key botanical on our gin. It was never going to be one of those big commercially viable projects, but it had a good environmental cause. A protracted meeting turned into a ludicrous meeting, to be quite honest, about how we could link up gin with certain animal species. And bats were discussed. I'd read articles about bats and the way they navigate using ultrasound, but I'd also read about the use of ultrasonics in food and production. Now this all happened in, I think it was February 2000. By the 23rd of March, as you know, we, as a nation, we got locked down and the world pretty much came to a stop. And quite possibly the most hated animal at that time became bats. They were the cause, as far as the media were concerned, of COVID. So we decided, obviously, to put the project on hold. It would have been a PR nightmare. Okay, so we're back. A seamless edit, except for the fact that the last time I hadn't got the microphone turned on. So I think it's probably important to just touch on what ultrasound is and its previous and current applications in the food and drink industry. So ultrasonics refer to higher frequency sound waves. So you've got high frequency sound waves, you've got low frequency subsonic sound waves, and then generally in between are the sound waves that most of us can hear in the form of speech, music, and general hubbub that surrounds us on a daily basis. In terms of the food and drink industry, ultrasound has been used to perform a number of functions. Generally, its application is for destruction or the homogenization of ingredients. When we're talking about destruction, it's generally either the breaking down of solid matter, the removal of gases, or the removal of specific parts of a solid, maybe oils, for example. Now, for the application of ultrasound in respect to our gins, we are looking at a process called ultrasonic cavitation. Now, ultrasonic cavitation is essentially what happens when you apply ultrasound to a solid matter that is in solution. So, to give you an example of that, we've got a bottle here that contains the botanicals that we would use to produce ultrasonic gin. We would add to this alcohol and water, so they become our solvents. Now, if we put those bottles into an ultrasonic bath that is filled with more water and run it for an hour, you start to get this happening. So we're starting to see the decomposition of the botanicals, and what was once a clear liquid is now rich in botanical oils. And those botanical oils have been stripped out because of the in part some of the maceration process, so just the fact that the alcohol in the water is going to help in the extraction of botanical oils, as it does with any typical pre-distillation maceration. But the addition of ultrasound that encourages this greater extraction. So cavitation effect. Now what happens here is each of those botanicals contains very, very small pockets of air, as does the liquid that's surrounding it. When you introduce sound waves, you are introducing energy. And high frequency sound waves mean that you're getting a lot of energy pumped into the solution and the solid matter and into those very tiny air pockets. Now every time a sound wave hits those air pockets, they absorb that energy and they will expand. And they expand because that energy is in part being turned into heat. Now as they expand, they are eventually going to get to a point where those small pockets of air burst. And when they burst, they disrupt all of the matter that's around them, shearing off bits of the botanicals. And those very, very small scale explosions can force matter to travel up to in excess of 1,000 kilometers an hour. That in turn hits other particles, other bits of matter. The whole concept is really driven by having a matter transference. So you are breaking stuff down in a solution so that it goes from a solid state into a liquid state or somewhere in between to create a slurry. We still got a lot of solid matter, but a lot of the oil, a lot of that soluble content is now in suspension in the alcohol and water, and that's what we're going to distill. So one of the questions I've been asked to address is how can sound impact on the flavour and the aroma of a spirit in respect to maceration and indeed maturation? Well, in terms of maceration, we've seen some really significant increases in the level of botanical extraction. Now, unfortunately, we don't have the luxury of a scientific laboratory that allows us to measure exact chemical profiles of our gins. However, what we do know is that when we'd been through the process of distilling and then dilution, we ended up shifting from a simple macerated and distilled product that was a multi-shot that would yield around 300 bottles to a product and process using the ultrasound where we had a yield of 500 bottles. So we're looking at a 60% uplift in the output, and that is wholly down to the fact that ultrasonic maceration process had drawn out a higher level of oil from the botanicals. We also noticed that there was a difference in the flavour profile. As part of the experiment, we distilled our botanicals after what I would call a standard maceration. So simply soaking them in alcohol and water, leaving them for 24 hours, then putting them in the still and running it. When we did this again, but actually included the ultrasonic maceration process, we noticed a significant change in the flavour profile. And it was, the best way to describe it is an amplification. The fruit notes, the slightly citric tart notes from the Bramley apple seemed to come out a lot more. The extraction of mint was higher. Elderflower, we got a huge amount of richness coming through on the ultrasonically macerated version as opposed to the standard maceration. And juniper had a lot more base notes to it. What we seemed to be missing, and in part this is down to the actual botanical makeup of this gin, was a lower level of top notes coming through. Now that's not to say that if we distilled using a citrus that we might not get that, and indeed that is one of the many experiments that I think needs to be carried out. So the use of ultrasonics within the spirits industry aren't just confined to the process of botanical degradation. They can also be used in the maturation processes. Famously, the guys at Ultrasonic Spirits, producers of the Hudson whiskey, looked into this, and I guess in a slightly less scientific initially slant, they were playing music in the storage and maturation areas where their bourbon was rested. And they felt that actually if you introduced lower frequency sound waves, it created a dissonance and a disruption within the barrel and the liquid that was contained within, and sped up the maturation process. And in fact, they actually took on the expertise of a sound engineer to try and find the perfect frequency that would help in this acceleration of the maturation process. Apparently it was a terrible racket, and they went back to playing it music. And you could at one point buy the soundtrack that your bourbon was rested to. So, it's functional, but also it gives great scope for some marketing activity as well. On a more scientific level, an experiment was carried out a few years ago at the university in Spain, in Cadiz, where researchers took a different approach, and rather than try and accelerate the aging of liquid in barrels, they started off with a spirit and dropped wood chips into it, and then subjected it to a blast of ultrasound. In fact, I think they did it for about 3 days. But within 3 days, they had extracted colour, flavour and aroma from the wood, the levels of which you would only expect to see after 3 years of a traditional barrel resting. So there's definitely a merit to using ultrasound, not only in the preparation of botanicals for higher oil extraction, but also for the acceleration in maturation processes. And it does lead to a question: could we start to use other things to give us flavour in the post-distillation process? You've got your white spirit, or you may even have an aged brown spirit. How can we introduce more flavour to it? I look around me now and I've got wood, I've got cheese plants, I've got a cheese sandwich, there's a leather apron. These are all things that we could extract flavour from, and there is no reason why, if it's an object that under ordinary distilling circumstances wouldn't give up its flavour, but under the presence of ultrasound would, then who's to say we can't introduce them? A piece of leather that is subjected to ultrasound, that is sitting within a big vat of bourbon, might throw out some really, really interesting characteristics. It's something that I think as an industry we could play with and explore to create some very exciting new flavours. Okay, so it's obviously important to consider the practical aspects of introducing an ultrasonic process into your day-to-day distilling. Our process means that generally we are running a 24-hour maceration prior to distillation. So for us to actually add in an ultrasonic maceration in its place isn't a significant disruption to what we do. However, if you're the kind of distiller that gets up and in the morning everything goes into the still, you run it for the day, and you want to clean it down at night, then you're going to have to consider that it might introduce an extra amount of time into your process. The scale and the type of equipment that you're going to use is going to come at a cost. A small ultrasonic bath is only a few £100s. However, if you go up to something in the range of a 240 litre capacity bath, then you're looking at around £5,000. And you've also got to consider a number of things that come with using a piece of equipment like that. One is that generally they are not designed for use in distilleries. So if you are using alcohol as a solvent, then you're going to have to make sure that it's in sealed containers. These things generate a lot of heat, they generate a lot of noise, and they draw quite a lot of electricity as well. So a large bath of around 240 litre capacity is going to draw 3.5 kilowatts per hour. The other option is the ultrasonic wands, and they generally are more expensive. You're going to use wands where you're actually using containers into which you will immerse a wand. You might have a closed cyclical system into which wands are immersed as well, and that allows for the continuous ultrasonic degradation of your chosen botanicals. Generally, wands are more expensive, but they do, more so than baths, allow you to change the range of frequencies that you're going to subject your botanicals to. So to fully understand the impact of maceration and its application within the spirits industry and the gin industry, I think there are a significant number of experiments that need to be carried out. And to stop me from doing any further edits this evening, I am just going to read off a list which is down here. Number one is individual botanical macerations. What happens when you take a single botanical, juniper, for example, and you carry out a standard maceration distillation process. That might be pot distillation, it may be vapor distillation, it may be using a rotary evaporator, but those processes need to be carried out alongside the use of ultrasound to break down botanicals in the first instance. And it might be that any one of those three processes really does complement the addition of an ultrasonic maceration. It might be that ultrasonic maceration works best in conjunction with one of those aforementioned distillation processes. The other one that needs to be considered, obviously, is the range of ABVs when carrying out the maceration, the ultrasonic maceration. Different botanicals are going to release their oils depending on whether the solvent has a higher alcohol level or a higher water level. How those botanicals are treated. Is there an advantage to crushing botanicals, or are they, under ultrasonic maceration conditions, going to just yield and give up their characteristics as readily without pounding them to death beforehand? Temperature management is an interesting one as well, because as I mentioned earlier, when botanicals are hit by sound waves, those tiny cavities of air are going to absorb that sound energy. It gets turned into heat energy. Generally, what we have to do is actually try and control the increase in heat, and that's part of your process, whether you are simply going to run your equipment for a given period of time, because some ultrasonic equipment can only be run for a certain period of time before it needs to rest and cool down, or whether you invest in equipment that has its own cooling apparatus surrounding it. Maceration time frame is obviously another one to consider. Literally, how long do we need to be hitting our botanicals with ultrasound? Is there a point where we are going to start extracting flavour and aroma profiles that we don't want? What is the optimum time range for any given botanical? And the frequency of the sound wave. Generally, most equipment that is used for the ultrasonic maceration processes within food and drink has a set frequency. Each of those botanicals might function and release its oils at a different frequency. And finally, the type of device that we're going to use. So are we going to immerse our botanicals in a solution in an ultrasonic bath, or are we going to have them swimming around in a solution that's pumped around a cyclical chamber which has ultrasonic wands set into it? So there are a lot of permutations to be investigated, And with each one of those tests, obviously we need to do follow-up investigation into chemical analysis, flavour and aroma to see which suits us best to help us best incorporate ultrasound into producing the best spirits that we can.